So here we are in Guatemala. We're going to come over here to Santo Tomas La Union de Suchetepeque, and we're going to come down to our project site, which is Clinica Medica Cristiana, and you can see it's in rural Guatemala, kind of right here behind the mountains that you look out from Lake Etalan, which is a tourist place over here. So you look out these mountains, and behind it are these villages, and that's where our clinic is. So we had this is a polycam model from the drone capture. You can see the drone pilot right there. So this is our hospital building, physicians' residence, some new development next to it that supports the hospital, and we are looking at putting an addition onto this hospital right here, which it was designed to expand this direction programmatically, and so we just need to structurally make it happen now. So we're going to tear down this little bodega and build a new structure starting right about there where that wall is. So let's look at that. So the existing building basically has these balconies that reach out towards the new addition. The idea on that was that it would make it easier to connect to because the primary foundation line is right here. So we kind of have cantilevered out, and the idea it would be the same on the new addition to have the primary structural line here, and then we're going to cantilever out to match up to this existing hospital. So that's the concept structurally here. Or okay, so we're going to look at a couple options here. So now here we are. In the Revit model, the existing hospital is over here. The new hospital, the addition, is on this side. And the blue modeling line down the middle is the earthquake joint. So just again, the ground's not quite in the right place, which is good because I can see under the building here a little bit. But you can see the structural line is back here, and we're going to cantilever out at each floor, and we'll show that in section. So cantilever out at the inpatient floor, and you can see it's important here on the inpatient floor to connect the existing ward with the new ward. So these are one continuous space. This will be one continuous space, and this option uses a earthquake joint that's 9 inches that wraps floors to wall to ceiling. You can see the existing building there and the new building here. And let's just look really quick how that goes floor to floor. So the second floor is a clinic floor. You can see the earthquake joint, which would not be blue when we're finished. It would be blending in with the existing building. I'm just showing it that way to just show the routing of it right now. So it's going to come up that first floor, and then where these are exam rooms on the right, existing exam rooms. Let's see if I can. So existing exam rooms along here with a patient corridor coming down here. So the patients come down, enter the exam rooms here, and then new exam rooms would be farther down. So, and then that would be a family meeting room at the end, kind of multi-purpose room. So you can see how that level connects on this side. We're going to go up to the roof. You can see the roof. This is going to cantilever further over. So, and then the roof deck connects. So this is kind of a utility roof. There's solar up here and some water tanks, washer dryer that services the hospital. And this is actually a call room now. It's been turned into like a little guest suite. And then on the roof for staff, we're going to have a exercise wellness room here. So with a place to have lunch, a little lounge, and some exercise equipment, which has the best view right out towards there's a huge mountain volcano out there. That's a great view. This is the physician's family's home over there. Anyway, I just wanted to show the roof is connected, and the expansion joint continues up along the roof. And let's go to the other side. The expansion joint continues around and down because on the other side we have the staff circulation area. So the staff circulation is separate from the patient circulation on the other side. So this expansion joint then, that's a little messed up modeling wise, oh well, will basically wrap down around through here. Now this roof, and you'll see in the images, is just a very flexible wood frame with kind of a laid on tile, plastic tile that would move just fine in an earthquake. Might get slightly damaged, but could be easily repaired. That's just a tile. So that this plastic tile, which is in pieces, it's segmented, so I think it would move just fine in an earthquake. So it's primarily the concrete structure that we're separating out here. So let me jump to the section really quick now that you've seen that. So I should show one other thing here. All right, let's go back to this really quick because one of our challenges that we have here, don't have this issue in the United States often, but since we built this hospital, the neighbor next door built their house over here, and in doing so, excavated down about 8 feet directly adjacent to the property over here, and we have about 5 feet off the property line. So luckily our footings go nice and low in the existing hospital, um, but our engineer would like to go lower over here because of this excavation that's happened in the property directly adjacent. So that means we're going to go down deeper. We're going to go ahead and do a basement, a storage basement downstairs. So the level that we were looking at, kind of the first level, is here, and we're going to have a basement down below. It's going to be retaining wall on one side, and then the other side would be that's going to slope down pretty quick, so there would be no retaining wall on the other side. Anyway, and then there's going to be a door on the back side and a driveway down to go into this storage. So programmatically, that's what you're seeing. A storage daylight basement, basically. The first level of the clinic is the inpatient ward. So you'll see the foundation wall and footing would be on grid line E2, and everything above that's going to start cantilevering. So we've got a beam here that's going to cantilever over for that inpatient floor. The clinic floor is going to cantilever the same, which is it's about a 0.68 centimeter cantilever there. And then there's a bigger cantilever on the top floor. That cantilever would be from grid line E2, which is that primary structural line. It's going to be 1.8, but we're kind of stepping over. So the actual cantilever from the floor below is just 1 meter. So we start out with a like 0.7, and then we go like 1 meter. I guess it would be a little farther if we did the math. But anyway, so structurally we got to figure that out. That this steps and cantilevers over as we go up, and then an expansion joint 9 inches is what I think I want to use. Separates the existing building from the new building. So that is so that's basically option, let's call it option A. I'm kind of waiting to finish off the design of this until we figure out what this connection actually is. Let's go to option B really quick, which is the seismic portal. Okay, let's look quickly at option B. So our Guatemalan engineer did not like option A, not for structural reasons, but was not able to find support for the seismic joint that wrapped up and around through the building like that locally. And so for that reason, not being able to find support for seismic joints within Guatemala, really wanted to have 2 separate buildings. So a completely separate building. However, the inpatient wards still need to be connected. And so I was looking for a product that might allow us to have 2 completely separate buildings, but connect that one floor. That's the very important floor to be connected. And so in that search, I found the Balco Seismic portal, which is designed to connect to separate buildings functionally with a portal that you can walk through, and allows those two buildings to be completely seismically independent, which is what our structural engineer was really after as far as his comfort level went. So basically, so that gives us this option, the Valco Seismic portal, and I actually haven't gone in here yet to see what this looks like with the portal there. So it would basically be, again, in a blue, we'd have that the inpatient ward, two separate buildings, but it would allow these two, this floor, this ward, passing through the portal, and then the other ward would be, there's 3 beds in there right now, would be connected. So there's a provider room down there. We also have another provider room right here for this ward, which is not updated anyway. So this product would allow this floor to be connected with 2 separate buildings. So then the challenge gets into, how do we connect? What do we do around this? That worked, but now we have 2 buildings, and we still need to get patients on the clinic floor across. So we still have to deal with this, which I think we deal with it with kind of like we did before, where this would cantilever kind of reach out and connect there. Similarly, on the other side, we got to get the providers across. This is the patient side. The patients have to get across. We got to get the providers across on the other side. So we've got, again, this gap and needs another cantilever across here. Anyway, ultimately, I just, as I was working through this option, it's like, well, why don't we just cantilever this whole floor over? Again, with the upper floor, we have this other gap we need to get across. Anyway, ultimately there's too much connection required on the other floors as well, and while that solves the problem on this floor, it leaves me with a lot of open issues design-wise up here. And I suppose these could be solved with just bridging across every place we want to go. That provider one needs to be enclosed, so we need to enclose that about the same. But ultimately, we still need the cantilevers. It would just be these small little bridges that cantilever across, as opposed to cantilevering the whole building like we did in option A. So right now, this is food for thought. It's unresolved as far as the upper floors and how we'd waterproof all this. And design-wise, this isn't quite as desirable, I don't think, either, as having it seem more like a continuous building with that earthquake joint down the middle. So, but I think on this level, it works really well, where we have that portal connecting that floor. But I don't know what to do yet with this option, with the portal, with the rest of it. So this is in preparation for my meeting with Balco to talk about the portal, and then also they have other seismic joint options. So I hope that helps. Thanks.